Hey fourth graders, Mr. Saul here for another science lesson. Today we're going to be talking about speed. Now speed is a part of motion and position, which you guys talked about last week. If you remember, motion is when something is changing position from moment to moment. Now motion happens all the time. Things can move back and forth, side to side, up and down, forward and back. All of these things are aspects of motion. Position is where something is compared to the moment it was before. So if I start, the ball's up here on the hill, and then later on, it's down there, it has changed position, right? It had a starting position, then it has an ending position. Now I have to be able to describe the motion or the movement that it went through. So I have to use words like forward, back, sideways, next to, diagonally, in front of, behind. All of these things are very important when I'm describing or talking about the motion and position. Now today what we're going to talk about is speed. Now speed is also very important and something that we use every single day. Every time you get in a car, you go for a run, you throw a ball, you're using that speed. Now speed is something that humans are really great at understanding automatically, but once we break it down, you're going to see that there's some really simple stuff that goes into calculating speed, and you can figure out just how fast anything is moving. So if you think about it, something like a cheetah can cover a very large amount of distance in a very short amount of time, right? Because a cheetah is the fastest animal in the world. Whereas something like a turtle would be able to cover that same distance, but it would take a much longer amount of time because that turtle is so much slower. So if you listened real closely, you heard that the words I was talking about were time and distance, right? Cheetah can cover a lot of distance in a short amount of time. Turtle can cover that same distance but in a much longer time. So what we're going to be talking about with speed today is time and distance. Alright, so what I'm doing here is I have my measuring tape and I'm going to measure out a set distance so that we can calculate the speed of these balls. So I'm just going to come down here and I'm going to measure out about 30 feet. 30 feet right here. Perfect. All right. So now I can check the speed of how fast these things are moving using these balls. Just like this. So if I roll these balls down the hill to my 30-foot point right down there, then I'll be able to see which one is moving faster. Alright, so let's see. Both of these balls went at least 14 feet, right? Now, which one moved faster? Which one got there first? Well, it was the black ball, right? Because it covered this distance in a shorter amount of time. Now, some of you might be thinking, Mr. Saul, this is really obvious and it's very easy to see which ball was moving faster. Well, the reason we have to start with these very simple explanations at first is because these ideas are going to get a little bit more complicated, and when we're doing good science, we have to have very clear definitions of everything that we're working with so that everyone can understand what we're doing. Okay, so now we're going to put some real numbers on what we're doing. So remember, we have our distance that measures how far something is going to go. Now we have to measure how long it takes for these balls to travel that distance. So to do that, I have my stopwatch here, which will just very accurately count the time. So let's back up a little bit, and I'm going to kick my first ball. We're going to see how long it takes for it to go. Let's just say, what is this, 13 feet? Yeah, let's measure to 15 feet. So I'm going to start as soon as I kick it and stop it as soon as it gets to that 15-foot mark.
Wow.
So I'm going to start the watch as soon as I kick it, and then stop it as soon as it gets to that 15-foot mark. So, ready, set, go. All right, so that took about 1 second. Yeah, that took about 1 second to cover that distance. So now I know that ball was traveling at about 15 feet per second. Now if I do a slower one, that one took about 3 seconds to cover that same 15 feet. So that means that this ball was only moving at about 5 feet per second, because I always want to go by the same unit of time. So in each second, this ball was able to travel at 15 feet in 1 second, whereas this ball was only able to move 5 feet in that 1 second. All right, fourth grade. So we're back home now, and I've put up on our whiteboard our little experiment that we did when we were out in the field. So if you remember, I've just rolled the red ball, and I rolled it 15 feet, and it took me 1 second for it to roll over that 15-foot distance. Then I kicked the green ball, and it traveled that same 15 feet, but it took 3 seconds to travel that same distance. So remember, we're talking about distance. In this case, that's our feet. And then we're also talking about t, or time, which in this case is our seconds, okay? So if you remember, we obviously know that the red ball was the faster one, right? Because it traveled that 15 feet in a shorter amount of time. So when we talk about speed, we talk about distance over time, okay? And you hear this all the time when people say something like miles per hour. That car was going 60 miles per hour or 100 miles per hour, right? That's miles is a measure of distance, and an hour is a measure of time. Now, we don't need to measure our balls in miles per hour because we're working on a much smaller scale or a smaller size of things, right? So instead of doing miles per hour, what we're going to do is feet per second. So how many feet per second did the red ball travel, and how many feet per second did the green ball travel? So teachers, this is a great time to pause and discuss with your students and look at how you can know by the numbers, using numbers as your evidence, which ball moved faster. So even though this is a very simple example, in the world of science, if you're going to say anything like the red ball was faster than the green ball, people are going to be like, how do you know? And you can't say, well, I saw it with my eyes. They'll say, well, I wasn't there, I didn't see it. So you have to provide your numbers, okay? So, like I said, teachers, pause, talk about which ball went faster, what is your evidence, and we'll be right back. Okay, welcome back. So, if you did the calculation to find out that the red ball was faster, then you would know that the red ball was traveling at 15 feet per second, okay? Because in 1 second, it traveled at 15 feet. Now the green ball, in 1 second, how many feet did it travel? That would be 5 feet per second, because you had to do some fancy division here and divide these 3 seconds into the 15 feet to figure out how many of those feet it could cover in just 1 second. Because as long as we're measuring by the same unit of time, we can compare. And we can even say the red ball was 3 times faster than the green ball, because I know that it traveled 3 times more distance in 1 second than the green ball did. Okay? So this is why knowing about speed is so important. Using that speed, we can gather numerical evidence to support our findings. So I can say that car was traveling this much faster than the other car, and I know because, and if you have those numbers, you'll be able to prove what you're saying. Okay? So thank you so much, 4th grade, for participating in our fun experiment, and I will catch up with you guys tomorrow.